Alright, so now let's talk about second equation of motion. And we know that we can derive equation of motion by two methods. First is graphical method and then algebraic method. So today we are going to talk about how to derive second equation of motion with graphical method. Okay, that is using graph. So we know that second equation of motion is this. S is equal to ut plus half at square. This is your second equation of motion. Here also we use velocity time graph. So this is your velocity time graph. The same graph we will be using. Okay. Now, third thing, we know that object is moving with uniform acceleration naturally. When we talk about equations of motion, we only talk about uniform acceleration, because with non-uniform motion, these equations of motion cannot be used. Now let's first understand what this graph tells us. See, first thing, slope AB, it is acceleration, that is A. So this slope AB is acceleration. This indicates acceleration, that is A. Then initial velocity. Initial velocity, it means U, it is indicated by OA, and initial velocity is at time 0. So here you can say that this OA is initial velocity, that is U, and this initial velocity is at time 0. So this is time 0. Then final velocity, that is V, and that is indicated by BC and at the time t. So this is BC, which is your final velocity. Why this is your final velocity? Because when the object started moving from here with the acceleration A, it has reached here. So this point B becomes your final position. Okay, and that's why this BC is your final velocity. And this BC, which is your final velocity, V, is at the time t. Okay, means after t time, this is your final velocity. Now, to complete the graph, we will draw certain lines, that is CB. Let's see here. CB means this BC, just to complete the graph. Then AD and BE. AD and BE. Remember, we are drawing from point B, BE, which is on y-axis, that is velocity axis, and from B, BC, which is on time axis, that is x-axis. And this AD, you can see here, this is equal to OC, and OC is time. We need to keep in mind all these things, because all these things are going to be used in our derivation. So, here we have drawn these lines. Now, suppose the body travels distance s in time t. See, this is our second equation of motion, which is s is equal to ut plus half at square. And that's why we have to introduce this distance s here. While deriving the equation, we have to introduce this point here, right? Which was not there in the first equation. So now, suppose the body travels distance s in time t. Now, we know that distance is equal to area between the slope AB and OC of the graph. So, we know that this area, okay, this area between this area is this space actually. Which space? Between the slope AB means this, and time OC means this. Means actually we are talking about this area. This is your distance. We have already seen all these things, right? When we were talking about distance from the graph. So this area is actually the distance traveled, which is figure O, A, B, C. Okay, so this is your distance traveled. Now, another thing is AD is equal to OC, that is equal to T. That we have already seen. This AD is actually equal to OC, okay, because they are parallel lines, right? And OC is T. One more thing here we need to know is BD is actually change in velocity. Now let's understand this again. See, this BD is change in velocity. Let's understand. See, this AO is initial velocity, and from this point the velocity is changing. So if we talk about this final velocity, in this final velocity, this DC is actually initial velocity. The reason is simple. DC is equal to OA, and OA is initial velocity. So in this total velocity, DC is initial velocity. So naturally, the remaining portion, that is BD, is actually change in velocity. So from this point, the velocity has changed. That's why this BD is change in velocity. Okay. Now, this much we need to understand from the graph. All right. So that now we can start doing our calculation to derive this first equation from graph. Now, using this graph, we can now say that this. See, this distance is actually area of OABC. Okay, so this is your area OABC, means this whole area. Okay, now here you can see that this area is made up of two figures. One is rectangle OACD and other one is this triangle, that is triangle ABD. So that's what we can write now. So this area of OABC is made up of area of OACD plus area of triangle ABD. Now we know the formula. Area of OABC is length into breadth, that is OA into AD, right? So OA into AD. So the multiplication of this will give you area. And area of ABD, we know that half of base into height. And for triangle ABD, this is your base, AD is your base, and BD is your height. Okay, so now we can understand this, that area of ABD is equal to half of AD into BD, that is base into height. Now, if we replace these values with their actual, what they indicate, we know that OA is actually U. So this OA is actually U, that is initial velocity. So now we'll replace these values. So OA is U, AD, which is equal to OC, and OC is nothing but time. So AD is equal to T. This half will remain same. And now we know that again AD is T. And now this BD, which I told you is change in velocity. We know that change in velocity means final velocity minus initial velocity. So instead of BD, we will put V minus U. Now this we will keep as a result 1. So this is our first result. Now, when I told you, when I was explaining the introduction part, I told you that to derive the second equation of motion, we'll have to take the help of first equation. So now this point will come. See, this is our first result. But from the first equation, we know that V is equal to U plus AT. And you can see here, this is V minus U. And if this U will come here, it will become V minus U. And V minus U is equal to AT. Let's say this is our second result. Now what we will do is, we will replace this second result, that is V minus U is equal to AT, in this first one. So now let's do it. So we know that the first equation is this. The first result is this. So U and T will remain same, half will remain same, this T will remain same, but now we know that V minus U is nothing but AT. So instead of V minus U, we will put AT. And now we will see that U into T means UT plus half, and this multiplication is AT square. And this is how we can get this equation of motion. This is nothing but UT plus half AT square, and this is actually our S. So S is equal to UT plus half AT square. This we have derived using graph.